This is my group's code demonstration for INSY7314, the final POE. So this is the international payment system that we designed to ensure security. So before I showcase the actual application, I'll just run you through the back-end code and how we secured our application. So I will firstly start off with the check auth. So this part. So what we do in this part of the code is basically we extract the JWT token from the authorization header, and then we verify the token's authenticity with the secret key in my .env file. So we put all secret keys, all um, database connection strings into the .env file to ensure security. And then, so basically, what we do here is we just extract that, or we verify the token authenticity with the secret key. And then we check if it's valid. And then we attach the decoded payload to the requested user. And then if it's invalid, it will obviously respond with a unauthorized with the invalid token error. Then over here, we do use to authorize the role. So we just checking if a role has been created in the database. So we check if a user is logged in and has a valid role. So this part, and then it compares that role, so either employee or customer, to the list of allowed roles. And then if the role is not permitted, it's obviously going to say access denied. So they're going to be forbidden from the application. Then I will move on to the seeding part. So in this code over here, I just create a connection. I just create a link for my connection string to my database. Over here, I have defined a salt, so that will be used for the hashing and salting later on. So over here, I create an array of users. So this will be the employee users that will be created or seeded in our application. So I defined attributes like name, surname, the username. So this username they will be used need to use to log into the application. Then the employee number, they'll also need that to log into the employee application. So to ensure security, I used UID. So that auto generates an ID for me. So it's quite a long string that ensures proper security and reduces the risk of brute forcing attacks. Then also the password, I put that into my .env file, the employee's password. So I put in the .env file so that it ensures security because it's not good practice to put it directly into the code. Also, I used, well, in a general purpose application for a real situation, you would seed a role, but then have a user change their password to whatever they want it to be. But in this case, the POE required that no password or authentication process should be allowed for this employee users. So that's why I just put all passwords into the .env file. And then similarly for the second user. So over here is where I seed the users. So I await for a connection. So I make sure that the database is connected to my application first before I carry on. Then I defined what the name of the collection is going to be, or the name of the database. And then over here, I define what the name of my table is going to be. So this was employee data. Um, Over here is just basically allowing me to, so sensing we inserting multiple users all at one time, we're going to use a um, bulk accessibility to insert users because we don't want to insert one by one. We can do it all at one time, unless compared to like for the users where we insert one. user at a time. In this case, we insert multiple users all at one time. So in this part, I use a for loop to iterate through the users. I hash each password for the user. Then I create a copy of the user and then have that copy use the hashed password. Then over here, I just see if a user is already in the application or within the database, and then I'll just update if they are there. And if they're not there, then they'll obviously just insert an entire new user to the database. So over here is where I execute it. Um, then it'll say the users have been seeded successfully, or an error will show up. Then I just run my script. Then for the staff, okay, so over here, I just define my database, I define my table, and then I created a limiter so it also reduces the ability for brute forcing attacks. So in this case, the limit is 10, so they can only try and register 10 times before they set on a delay. Uh, so then it'll just say login too many times, you'll have to wait. So that's what that part does. And then over here for the post. So this is what's done to allow the employee to to add their details and enter the application basically. So this is what they use to use the application. It's their authentication process. So over here, I define the limiter from above. Um, then over here, I say find the user within the table, and then so find this user, and then if it's incorrect credentials, obviously I made it ambiguous so that they don't know what exactly is wrong with it. So I say check the username, employee number, or password. And then over here with the password, I compare the password with what's inside the database. And then if it's obviously not valid, then I'll say check credentials, ensuring ambiguity so that they won't know what exactly is wrong. Um, Over here is basically just a token that I create for the user once they enter the application, which lasts 1 hour. So this ensures that the user is authenticated at every step. Over here, this was just mainly for testing this message. And here's if there's an error that occurs. So over here is the database file. So over here, I get my connection string from my .env file. I create an options um, object. Then I create a Mongo client, and then I just create a connect function which connects it to the database. And then there's a transaction JS. So also a limiter over here so that they can't brute force multiple transactions at one go. They have to have a break between so that also doesn't overload servers. So this is just the posting part. This ensures that a customer is authorized to make transactions. So over here we use JOI, uh, or Joy, I'm not sure how it's pronounced, but basically we use that to whitelist our data in that's being entered. So we ensure that it all meets specific standards. Then over here we just create a model. So the status will automatically be set to pending. Um, then we insert the transaction into the database. And then if there's any failures, it will say transaction failed. Over here, we use a get. So this is used to display it for the employee role over here. And then this is just basically finding all transactions and displaying it. And if there's obviously an error, it'll just say that. And then the patch part. So this is for when a employee wants to verify that a transaction is correct. So in this case, it's authorized only to an employee to do this. So basically, you just update the in the table. So you find the ID, then you just set the status to approved. And then if obviously there's no transaction for it, there will be error displayed, or else there will be transaction approved, or based on different errors over here of why the application couldn't or the transaction couldn't be approved. So I think that is it for the back end. Um, oh, so for users, there was so users has a very similar output or well code design. So over here we have salt. We defined our database. This defined our table. We have a sign up method. So this is where the customer can create an account. We use JOI or Joy to whitelist our data. So ensuring that it's alphanumeric, it's a minimum of 3 characters or a maximum of 30, and it is required. So all of these ensure that a user is correctly defined when they are authenticating. And then over here is a regular expression that just basically makes sure that the password has lower character, upper character, special characters, and is 8 characters or more longer. So that's what this part is for. So then over here is just a validating. It's checking over here. It's checking if ID is already in use. Over here we hash the password. We create a model with all the details. We define the role as a customer. Then we insert the user. And then if there's obviously any errors, we'll say there's an error. Then over here, we also create a limiter. So this is to ensure that there's not too many login attempts, so we can't brute force. And then here's the login route where we add limiter to it. So we find one username and account number. We check if it's the username and account number is valid. Then we will say incorrect credentials if it's not valid. And then over here we find the password, we compare it, and then we say if the password is not the same, then we'll say obviously for ambiguity, we'll say all account number, username, and password is incorrect. So we'd look at one of those details. But if the password is valid, we create a token for them that they can use the application that will last 1 hour and uses our JWT secret that's in our .env file. Um, then it'll have a success message, and if there's any errors that occurred, then it will say failed and give a description why. So here's our server.js. Um, Basically here we just basically import our libraries that we installed from Node, and then also import from our routes, like our middleware and from transactions. And then over here, we initialize the express to app, and then we also create a port. We initialize a port. And then over here, we use Helmet. So Helmet just protects us against common web vulnerabilities like clickjacking, cross-site scripting, and I think MIME type sniffing, I believe. And then over here, we create a content security policy. So this basically just upgrades HTTP requests to HTTPS if needed, and it also just prevents injection of external malicious scripts from yeah, basically just stops external scripts from entering our application. So in case it's malicious. Um, Over here we use, I believe HSTS is HTTP strict transport security. So this basically just ensures that the browser will remember we use H to always use HTTPS for the site for 1 year. So the 1 year is this calculation over here. Um, And then over here is just express core middleware. So over here we define 10 gigabytes to prohibit large, to prevent massive payloads from entering our backend. Then over here we use cores. Not sure how to pronounce it, but basically all it does is link our backend and front end to ensure they're communicating through HTTPS. Yeah, they basically just our link to ensure we're transacting through HTTPS. Um, then over here we force HTTPS, so this is a in our middleware. It's imported. Um, we imported it here. So where was I? So basically, this just checks if we're on HTTP, it will force us to go or redirect us to HTTPS automatically. And then our trust proxy being false just tells Express not to rely on reverse proxies. Then we create a rate limiter. So this prevents like single IPs from making more than 100 requests every 15 minutes. So this is the 100 requests, and then this is our calculation for the 15 minutes. Um, and then I just did a conditional if statement. So because we're using MK cert certificates, we can't really work with the CSRF protection well in local development. So if our website was pushed to production, so maybe it was deployed on Render or Azure on the cloud or something, this would end up um, executing over here. So we would be secured on the web. But because and then the front end will send it back with headers, uh, the X, the XSRF tokens with every request. But because we're working on a local environment, it doesn't execute well. So I had to disable it for a local environment. Over here, I just define our routes. Here I connect to our database. Over here, it's basically this code over here, but I modularized it to also the HTTP to make it more coding better practice. So it basically just reads our certificates and our keys and connects to an HTTPS. Um, and then here we listen for the port. So now I will go through https.js. Okay. So over here, I just import HTTPS, FS, and HTTP. So over here is the function where I force HTTPS. So if it's not automatically on HTTPS, it'll be redirected. It'll redirect the user to HTTPS. So it will force HTTPS. Um, and then for the create HTTPS server, we basically just define our key and certificate, and then we create an HTTP S server. So we load our certificate, then we create a small HTTP server, and then we return the full HTTPS server here. And that is it for the server and HTTP. Okay, and then we also did unit testing for the staff and the users. So over here, we just mocked certain details and returned details. Same with the staff. So if I had to execute to show the unit tests, cd backend, and then npm run npm test. So as you can see over here, we go through staff test.js as well as user test.js. So this is just because it's not fetching the data from our database. So it's just one of the failure messages, but all the tests do run and complete. So test suits, which is two, which is our staff and user, and then we did 10 total tests. So for both the employee login and for the user's login or the customer login. So if I were to show you the database, currently there's only two employee users that are seeded into the application. So those two users are um, these two users so far. Uh, so if I go to the clusters, browse collections. Okay, so this is the database we are using. So we have employee data. Okay, this is transactions. Okay, so currently we have these two users in our application. Oh, and also for our application, we defined that we seed users automatically because it's better practice to seed users manually than have it seed whenever you execute the application. So firstly, I'll say cd backend, then npm run seed. But before we do that, I will create a new user. So over here, Sean Chetty, Sean Chetty 1. Then, so we have our username, employee number, password, and we define our role as employee. So if I say npm run seed, it should seed my users. So if I come here, refresh, so over here you can see the new user has been seeded in with the password hashed over here. So now if I create a new terminal for the backend and then say npm run dev, I connect to port 5400 for the backend and then connect to MongoDB. Then another terminal for the front end. And then npm run dev. Okay, so for transactions, I currently have these transactions that are already approved. So I'll just have to create a new user and then approve those transactions. So I over here we select if you're a customer or employee. So over here, I'll create an account. So this is for creating a user account. international payment. Then for the username, we can say international user. Then for the ID number, and then the account number. So I'll just use this and then change that. And then for the password, it has to meet uh, normal details. So international 123 exclamation. So I can save that. Okay, so then let me save it. International 123. Let me just type that there, international 123. Okay, perfect. So I've successfully signed up, and now I just log into the account. So customer, the username. Ooh, I forgot the username. International. So this user over here. Then I add the account number, which is this one over here. And then I put in my password. So it'll say login successful, and then it'll redirect me to the make transaction page. So here I can say 15,000. I can select the currency. So I'll say South African rands. Payment provider Swift. Recipient account number. Let me just take one from here. Recipient name and the Swift code. So if I pay now, it'll say transaction successful. So if I go to transactions, the new one is created over here with a status of pending automatically. So 15,000 recipients. Okay. So now if I log into the employee um, account, so does this user created here? Just choose the username, enter the account number. So because this is auto created, it is a string instead, and then it changes to employee number, and then the password is this one that I have inside my .env file. And then if I sign in, it'll say login successful. And then once I'm here, I get to see a list of all transactions that have been made. So over here, there's this transaction that was approved, this one, this one, this one. So also to ensure that a transaction is being correctly verified, we have pop-ups that ensure to show that a transaction cannot be reversed once it's permanent. So if I say verify Swift, it comes up with this pop-up over here saying the Swift code, and then to please confirm the Swift code. And then once verified, you can approve the transaction. But if I say cancel, it still stays as verified. And then if I check the database, so transactions, it still stays as pending. And if I say verify Swift again, proceed, and then it says final confirmation. If I press cancel again, and then refresh. It's still saved as pending, but then as soon as I say verify Swift, proceed, and then confirm, it will approve the transaction. And then if I go back to my database, it will be now saved as approved. Thank you very much.